Good afternoon, folks. Welcome. My name is Gord Cooke, Building Knowledge Canada. Welcome to our critical Canadian building science webinar series sponsored by Enbridge. I got a few guests to introduce to you in just a moment, but we'll just give people another minute or so. I see new participants coming, so we'll give them just a minute or two grace, and then we'll get started. This particular session, though, is a particular focus on renovation, retrofit, decarbonizing existing buildings. And we've titled it Air Tightness plus Air Source Heat Pump, being the slam dunk for reducing carbon emissions in Canadian houses. We'll actually go a little deeper than that, but we thought that might be a title that got people thinking a little bit. Is it really that easy? That if that's all we need to do, but we will chat about that as we move through. But again, we'll just wait another minute or so to give people a chance to get on. And Stacy's putting some elements in the chat if you're interested. This session is being recorded, so keep that in mind. You're put on mute, and what we would ask you to do so that we can answer questions correctly and log them is to put them in the Q&A. Hopefully we're all Zoom versed. By all means, say hi in the chat or add comments in the chat. But if you have a question, it's better if it comes in the Q&A because then it's properly logged and we make sure that all respondents get it. So important to do that. And good, we're almost at 100. I'm going to wait. Maybe it'd be kind of nice to have 100 people before we get started. So do we wait one more? Is 99 close enough to 100, do you think, Tom?
Thank you. Round up.
Good. All right, well, let's get started. Again, I'll say my name is Gord Cooke with Building Knowledge Canada. We're always very pleased to partner with Enbridge on this series of what we call Critical Canadian Building Science webinar series, where we try to tackle in a succinct way every month or so specific topics. And one area that we often get comments and questions about is, what are we going to do about existing housing? It's nice to think about the 200,000, 300,000 houses that we build new each year. But what about I'm going to use the term 18 million existing houses? What are we going to do about those in terms of our efforts from a building science perspective? So this particular session, we've titled Air Tightness Plus Air Source Heat Pump as the slam dunk for reducing carbon emissions by 50% in Canadian houses. And that's a bit of a challenge, I think you'll know, for us to be able to show you that this can get done. And I'm very pleased, and he'll introduce himself in a minute, to have Tom Grochmal from TrimTab with us and Brendan Leitart with us from Enbridge. And so, Tom, we'll go to the next slide, if you wouldn't mind. And so, Brendan, if you wouldn't mind, just introduce yourself. You were saying that where you come from, a little bit of your background, I think would be useful to the crowd.
For sure. Yeah, Enbridge is, I'll start off. Enbridge is proud to be a sponsor of today's webinar, and we're really excited to be involved with this conversation today. I'm Brandon Leitart, and my role with Enbridge is focused on cultivating and managing relationships with residential HVAC professionals in Ontario. I'm also involved in a few other strategic initiatives to ensure Enbridge is driving reliability, affordability, and sustainability in the residential HVAC market. My emphasis will be on new construction accounts. However, Enbridge does want to ensure that we're supporting all of our HVAC business partners with education, clear communication, and tailored natural gas solutions. Before working with Enbridge, I was an energy advisor for 3.5 years. House, MERB, Energy Star, New Homes. So I do have a lot of experience in that renovation retrofit space, and I'm happy to kind of share some commentary on that as we move through the presentation.
Thanks very much. And Tom, the next slide. And Brandon, maybe you can with that.
Yeah, I'll take away on the next few here. So we want to start today's session by acknowledging that the land on which we gather is the traditional and historical lands of the original people of Turtle Island, who have been the caretakers of these lands since time immemorial. Today, this gathering place is home to many First Nations, Métis, and Inuit people. Our acknowledgement of this reminds us that our great standard of living is directly related to the resources of and relationship to Indigenous people, and we have a responsibility to honor that.
Thank you.
We can move next. I'll briefly mention our energy conservation programs for residential new construction, which are incentivizing builders to build beyond code. And these are strategic initiatives designed to remove barriers and actively promote the adoption of energy efficient technologies or practices. Next. So the goal of our Energy Star New Homes initiative is boosting the market penetration of Energy Star or equivalent homes in areas that have historically had low adoption. Builders or developers can contact your regional Enbridge rep to confirm which municipalities qualify for the offer. And if you aren't sure who your regional rep is, I'll be happy to pass their contact info along to you. The homes that are being built must be built in an eligible municipality within the Enbridge gas service area. Energy Star homes are on average 50 to 20% more energy efficient than a home built to the minimum code. And builders do have flexibility with their construction to achieve these efficiency gains. A variety of HVAC equipment can be used, traditional, hybrid, or dual fuel air source heat pumps and electric heat pumps. Achieving higher air sealing targets from the minimum requirement is honestly one of the most effective ways to get those efficiency gains and really improve the comfort of the home. Eligible builders can claim incentives of $1,650 per home for up to 50 homes per year. And just one thing to note on this program is that it is planning to wind down at the end of the year. So if you do have interest in this, we would encourage you to contact us as soon as you can. There has been funding reserved for 2025 for those participants that do wish to enter. Next. So Net Zero and Net Zero Energy Ready. This is a great program for builders who have not previously labeled net zero because of the expert knowledge provided through our workshops and trainings, which do include trainings tailored for your trades and sales teams as well. Our net zero program is really designed to guide builders and make that first step of building net zero much easier. So the discovery home that you'd be working with us on in these workshops must be located in an Enbridge gas service area. And similar to the Energy Star New Homes program, air source heat pumps and higher air sealing standards are great additions to these projects. Your project must be in the pre-design stage when you apply. And you also have to be a builder member of the CHBA by virtue of being a builder member of your local Ontario HBA. That's it for me. So
Thanks, Brendan. I was very appreciative of, and some who are on this call may have been on a call this morning, Enercan, sponsored by the IESO and Enbridge and Natural Resources Canada on the newest of the retrofit programs, the homes program. You're familiar with that program, I'm sure, as well. That's kind of nice to see that one back in and has huge application as to what we're talking about today. So lots and lots of activity out there, Brennan, that's being supported by Enbridge.
Yeah, for sure. The home renovation savings program is, there's a lot of, just like a lot of these retrofit programs, there's a lot of interest in them. It's a little bit different with the HVAC contractors in the single measure stream. So if you're doing cold climate heat pumps or geothermal, those heat pump installers need to get on the approved list. So if there's any HVAC contractors here, apologies if it's been delayed. We just had a huge influx after January 28th of contractors to approve. And Enbridge does want to make sure that the contractors getting on that list, that they're well trained and provide all the proper certifications. So we're kind of vetting to prevent shady companies to kind of getting involved, because that has been a little bit of an issue with some past programs. So we're that's part of why we developed that contractor list, is to ensure that customers doing these retrofits do have trustworthy contractors.
Thank you. And so let's move on to the housekeeping, and I'll just say, as I've mentioned earlier, if you have questions, put them in the Q&A. I see there's one question there at the moment. I see some nice comments in the chat. Nice to see you, Dan, from Longmont, Colorado, and Zoran from Linvest. Thank you for being on side. I will remind you, and I know our crowd is very thoughtful and considerate, but be respectful in the chat. Thank you for your comments. That's great. You've already noticed that Stacy's putting things in the chat you'll find useful. So if you need any help with tech concerns or general inquiries, certainly let her know. I'll mention again, the webinar is recorded. You're going to get a link. You're going to be asked to complete a Survey Monkey. That's always really important to us following the presentation. And then you'll get the links to the presentation materials. Closed captioning is enabled if you require a live transcript while the hosts are speaking. It's between the record and reactions buttons at the bottom of the screen, if you wouldn't mind. And Tom, on to the next slide. There we go. Stacy, you always like to figure out who's here. If you could run the polls for us, that'd be great. Stacy. Oops. There we are. So first, let us know where you're located. And thank you. Oh, that's quick. You guys are learning this real quick. I love that. Almost 100% participation. Just let that play. Good. And thank you for that. Are we showing the results? I think we're showing the results now. Most of us from Ontario, I guess, but nice to see folks from across the country. Thanks for doing that. From BC through to the east, and then a few from United States as well. Thanks very much for that. Appreciate it. And next, your occupation. What keeps you busy each day? Again, thank you for your quick response. Always important to us. The quicker you put your response in, the quicker we can get going. So that's great.
With all those other ones, Gord, I'd love to know where we've missed their job titles.
Yes. There's a bunch of others. Those who put in other, if you wouldn't mind putting in the chat what it is you do to make sure that we one, capture those for future, and then two, make sure we can speak to any issues you might have. So please, by all means, put in the chat if you wouldn't mind. Great. And so a really nice chunk, about a third, builder renovators, architects, thank you, energy advisors, energy evaluators, thank you. That's really nice. Oh, nonprofit. Oh, hey, Evan, how are you? Nice to see you. Your name came up this morning. So nice to see your name again. And the nonprofit sector, great. Good. Well, thanks for that. We really appreciate that. And I think we'll move on from there. Stacy, if we can, there we go. And so I would like to introduce you, or have him introduce himself, Tom Grochmal. Tom, I've known you and your family for literally decades, but tell folks, just if you wouldn't mind introducing yourself, go off mute there, and help us understand who you are and what it is you're doing.
Yeah, hi Gordon. Thanks for having me here and the chance to tell my story. Tom Grochmal. So I'm 2 years into starting up my own contracting business and formerly an employee of Enbridge and a professional engineer. And I'll look forward to sharing more about what I'm up to these days once I launch into my segment here.
And so you watched your dad all those years. Some may know Roger, his father, Atlas Care, a really good, responsible HVAC contractor in the Oakville, Toronto area. And Tom, you watched your dad all those years doing contracting, and even still, you still wanted to become a contractor. So, more general contractor than HVAC contractor. But I really respect the fact that you're following in your dad's footsteps. So thanks for that.
Yeah, no, he was a good role model.
Yeah, he's a good role model. Actually, a great gentleman. Next slide. Not you need to hear much from me, but I'm just I guess the founder of Building Knowledge Canada. Been in the industry since 1984. I got my start designing and selling something called a heat recovery ventilator back in 1984. I will challenge you, who knew what an HRV was back in 1984? And you can imagine trying to introduce that to the industry. And in the context here, if you thought it was tough if you think it's tough to get heat pumps introduced into the housing world, imagine how difficult it would be to put something called a heat recovery ventilator, which was a brand new category of product back then. And so I'm going to say, if I could introduce HRVs to the industry, certainly all of us can introduce and take up or get good impact out of heat pumps. So I'll just encourage you that we can do that. So thanks for that. And Tom, our next slide. So what I want to do is quickly just outline. I'll do it just a little bit on, what are we really trying to accomplish and what are the challenges. I think most on this call will know it, but I just want to put that in your minds. We'll do a little bit at what's happening at the policy level because Tom's experience there. I asked him just to speak now being out of Enbridge, just to speak to what's been happening or what did happen and where things are at. But the real key here is to think about how do we scale this up? How do we know we have to do a lot more with heat pumps and decarbonization. How are we going to do that at scale, not one house at a time? And what Tom's going to share with you is these practical approaches and the success he's had. And seeing it as a bit of a model. I think, Tom, you would say it was almost like a pilot to get this done. And he's going to share with you what he thinks the next step should be. And again, I'll remind you, any questions you've got would be great. So we'll go to I'll say my first slide, if you will. And I'll just spend a few minutes with you. We've all seen this before, and if we haven't, we should have. That is the goal, the international goal, the corporate goal, everybody's goal is to get to zero carbon emissions, zero greenhouse gas emissions, zero carbon dioxide emissions by 2050. And if you think that's impossible, I was just on a flight yesterday, United Airlines coming through Chicago, and I was pleased when they told me that I was being flown on a renewable jet fuel. That is, United Airlines has said that they're going to be zero carbon by 2050. And as a start of that, they've already put a renewable fuel depot into O'Hare Airport. So they're a long way from being zero carbon, but they're working towards it. I thought that was interesting. So we know that's the goal. We know that buildings are a big part of that, 12% of emissions and 18% when you include electricity. We know there's 18 million dwellings in Canada. We know we've done a pretty good job in new housing. We know that most of those houses are still going to be around by 2050, and about 15 million of those 18 million need to reduce their consumption and switch to low carbon energy sources. You're going to say, what about the other 3 million? Well, some of us would say they're new enough, good enough that we probably can just switch fuels on the newest of those houses and the better of those houses. But there's these 15 million, and how are we going to do that? And understanding that our current rate of renovation is significantly below the 3 to 5% per year needed to hit this target. Imagine that, right? 3 to 5% per year, 3% of 15 million. Do that math. Are we able to do that each year if we're going to make a dent in this zero emissions? 3% of 15 million. That's a lot of houses. What's that? 450,000 houses a year? That's a lot of heat pumps. City of Toronto has already said they want to get to zero emissions by 2040. They put out a number like 450,000 heat pumps, 8.3 million windows are going to have to be replaced. Clearly, we can't just do this one house at a time. And we are going to need to transform the entire process in order to get this done. Next slide, Tom. And I just want to show you one. This has been the process to date. And Brandon, this has been your experience as an energy advisor, right? You find and motivate a homeowner, whether that's incentives, whether that's marketing programs, whether that's advertising, whether it's mouth to mouth. We try and find and motivate a homeowner. We conduct an energy analysis. We recommend changes to get loads as low as possible and low enough to make electrification viable. This house, I happen to know intimately, it's my son's house. It's an old house. It's a cobbled together old cottage with different segments to it. The heat loss on that house, because I did one, the heat loss on this house, uninsulated crawl space, really poor windows, was about 72,000 BTUs. That would be a 6-ton heat pump. And anybody on this call who knows residential equipment would know that you can't put 6-ton heat pump into this house. The ductwork isn't big enough. The electrical capacity isn't big enough. So what do I got to do? I got to find a way to get the loads low enough that I could realistically put a heat pump into this house. And then after all of that, I got to motivate the HVAC trade to embrace the switch. Because one of the challenges we've had is how do we get HVAC contractors to recognize the changes that have taken place in this house and make this switch. Brandon, if you're there, I'm sure you dealt with this, of all the customers you dealt with in doing energy audits. I suspect you would have said one of the biggest challenges was finding contractors that would understand what you had done and what you would recommend it. Do you think that's a fair statement?
Yeah, I think that's fair. I think a lot of the HVAC industry, or at least, you know, a lot of the homes that I was a part of, they were kind of using the rule of thumb to size their equipment. But there was a few that would ask for the EnerGuide reports, and they would look at the heat load and kind of consider that. But it also, I think, you know, like you said, you can't just put like the ductwork is a big factor in the equation as well. So,
Right.
you know,
Thank you.
there's, yeah.
Good. And we'll go to the next slide. And just so you know the history of this house, so the energy audit was done, and we did find out that most of the heat loss was associated with down the bottom right there with the basement and the air leakage, roughly 40% of the heat loss. So what do? Before they moved in, improved the air tightness, got it from about 8 air changes down to about 3 air changes. Replaced some of the windows because some of them were really rough shape, some of them were newer, insulated the crawl space, and ultimately added a heat pump, and which was really useful because they ended up getting air conditioning out of it. They kept the gas furnace, which was fine, but really the understanding of the process, it took an energy advisor plus 4 contractors over a period of about 4 months in order to get this one house done. Now, next slide. It had some really nice pieces to it, right? A tremendous success, much better comfort. The air quality, you can imagine, an uninsulated crawl space. Ooh, man, it was smelly in that house. Less dust, less noise, less bugs. Interestingly enough, about equal energy costs, because that's interesting, right? You switch to a heat pump and your electricity costs go up, your gas costs go down, but electricity is more expensive in most cases than natural gas, even when using heat pump. But my son was able to say, well, the cost is about the same. We save a little bit of money, not much, but they really did it for the lifestyle. But the point of this slide, and Tom, you'll understand, that's one done. We got one in 4 months. Man, we're going to have to be a little quicker. And if I could go to the next slide and bring Tom back into this conversation. Your whole piece here was about speed and scale, Tom. And you will know when you're at Enbridge, let's just talk about that a little bit. We've had for about 30 years a pretty good understanding of how to get an individual house done, the process of energy modeling and so on. But what you're interested in is on the policy side, at least as a starting point. What did you see in your world, and what made you want to switch to contracting business?
Yeah, good question. I'll say just for everyone's background that up until about 2 years ago, I was responsible for the design of energy efficiency programs at Enbridge Gas, programs similar to what Brandon was sharing earlier, right? And when you work in that role, you sort of got to have a market transformation mindset. So maybe I'll give a bit more, maybe a programming perspective than a pure policy perspective. Although at the time, Gord, they're just, pressure was ratcheting up and continues to ratchet up from folks like the Ontario Energy Board and the province to do more, to get conservation programming aligned with climate policy. And what I mean by a market transformation mindset is just the mindset of how to do things at scale and understanding the at scale issues that prevent mass market adoption, right? I mean, Enbridge doesn't, or the IESO or whoever's running the program doesn't want to do these things by the hundred. They want to do them by the thousands, if not the hundreds of thousands. When you look at the scale of the problem that you've laid out, Gord. And so just, when I was in that role, kind of 4 or 5 years ago coming into it, there's a lot of focus on cold climate heat pumps and their emergence. And then from a utility perspective, we were really focused on sort of the at scale issues there, grid readiness, the ability of contractors, like you mentioned, the size and select equipment. And even just understanding from a homeowner's eyes how you help them avoid a perception of sort of risk or compromise so that we can get beyond early adopters and really drive adoption. So, and maybe just the one example I'll point out since you asked, Gordon, you'll remember this because you were involved with your team, was Enbridge ran a pilot program back in 2021 in the London market as sort of their first attempt to incentivize homeowners to make the fuel switch to heat pumps. And we if you recall, we partnered with like the municipality, we partnered with London Hydro, we partnered with like leading manufacturers in the HVAC and their own hand-picked contractors to see if we could really, start a local market. And there was marketing, there was training, there was rebates, there was new controls deployment in order to help homeowners manage the perception of possible runaway hydro costs. And I think, if I was to take one thing away from it and definitely influence what I'm going to share in my presentation, it's just that, the elements of scalability. It's sort of like if you have a good plug and play solution, like, and I think, I don't think anyone would disagree with me, heat pumps are pretty good. They install like air conditioners. There's a few details and there's some sizing considerations. But if you have a good solution like that and you have, service providers and contractors that are really well equipped to capture the opportunity, you can get results. And I was pleased in that one example there. After one summer, we got 100 hybrid heating systems in London deployed, and it wasn't just friends and family of utility employees and tech savvy youngsters that were taking up the offer. It was a good cross section of people who didn't know what heat pumps were until they saw the marketing, and then they had a good contractor experience with one of the program participants, and then the incentive was like the icing on the cake. And then the province picked it up and they rolled it out to a bunch of communities after.
So yeah, we went from, that old adage of do 1, do 10, do 100. And now we're at the do 100, right? We got to get to that level. And thank you. So moving away from one house at a time and thinking about these kinds of programs. So yeah, by all means, Tom, take it away. I'll pipe in now and again, but folks, you're going to be really interested in seeing what Tom's been up to and one demonstration, if you will, of doing it at scale.
Okay, cool. Thanks, Gord, and thanks, Brandon. Okay, I'm going to tell my story in 3 parts, folks. In the first chapter is just a quick overview of the business I started and why I started. It's called TrimTab. Then I'd like to talk to you about just sort of the thinking behind our thinking behind scaling up retrofit solutions. And then the last piece is I'm going to share with you a project that we have underway and some preliminary results, which will then put to the test sort of the whole thesis of this webinar around, is heat pumps and air sealing a winning combination for a lot of homes. Now, on TrimTab, at our core, we're a multi-trade contracting business that delivers turnkey energy retrofits. The key trades are listed here on the slide. You see photos. This is the work we do from our actual projects. We insulate, we do electrical, we repair envelopes, we do air sealing. And this approach ensures that there's a certain convenience for our clients, no doubt, to have a one-call sort of turnkey provider. But to me, it's also about just making sure that you bring the right solution to these complex projects. And that you're not, sort of viewing a multi-measure problem sort of through the lens of a single trade or with a bias for a particular product. My father who's a heating contractor, used to say, if you live life like a hammer, then sort of all the world's a nail. You know what I mean? And we want to try and avoid that. Now, part of also being a turnkey contractor in this space is having these other capabilities that you see on the slide, the ability to do testing and measurement and design. And it's probably what's a little bit different about us. And the reason it's important is because retrofit projects, as we all know, tend to have performance goals. You're trying to lower energy costs, you're trying to lower carbon, you may be trying to improve your indoor environment in some measurable way. And it's sort of, if you're focused on improving the efficiency and sustainability of homes, like how do you know until you actually measure? And so this is part of our capabilities here. Now, buildings are ultimately about people, right? And a lot of our work is in the affordable housing space. We serve boards, whose mission is to serve tenants and us too. Like we are there to serve the people who live in these buildings. And so our mission really is to renew housing and inspire better living. And these are examples of the people we serve at Trim Table. These are tenants. And, we try to get them all smiling. Some of them are receiving retrofits, so sure they have a happy reason, but a lot of them, not everyone is. Some of them are just the neighbors. But, when we roll into a neighborhood and we start doing retrofits, we really try to, it's important to us that everyone sees some sort of benefit. And as we get more experience, we find ways to do that. But, just a quick story, one of the easiest ways that we endear ourselves in the communities we serve is that when we show up and we start doing a retrofit and we're starting to do a bit of demo and we got to do some waste removal, we'll talk to the neighbors and we'll say, hey, can we take away that junky piece of furniture? Can we grab that old pool table and just do a little bit of cleanup right off the hop? And it's amazing how much goodwill you can just generate from a small gesture like that. But that all stems from the mission. Now, just one more piece about Trim Tab is just the opportunity focus, and we've alluded to it. I've personally been fascinated by this challenge of how to do scalable retrofit solutions. It stems from my experience as a program designer working in utilities. And I was particularly intrigued about, is this possible with envelope upgrades? I think it's an especially compelling problem as heat pumps proliferate because there's natural synergies between envelope upgrades and fuel switching. And so I want to talk a little about some of the thinking behind that in my next set of slides here. And I'll just, I call them principles of speed and scale. This isn't meant to be an academic treatise. But some of the thinking that has guided the project I'm going to show you is captured here in the next couple of slides. The first one, as you can see here, says capture lost opportunity. That's a program design principle. What we do know is, envelope upgrades are often a component of space modernization and not always done in and of themselves. And there's actually a lot of renovation opportunities out there that aren't captured today, as stated here. And these are facts I've pulled from my own research. A lot of homes trading hands, over half a million homes trading hands every year. In the rental space, CMHC says that 1 in 8 rental units are turning over. Now, it doesn't mean they're all deep energy retrofit opportunities, but I think they're all potentially opportunities for some sort of energy efficiency improvement. I think at least an air sealing opportunity at a minimum. And so that's what got my wheels turning. The second piece is segmentation. Housing stock is diverse. We all know that. One solution doesn't fit all, but maybe it fits a meaningful segment. And so this is where you got to dig into the history of home building. And I've been fortunate. I'm not a building science guy by training. I've been fortunate to have a lot of good training from folks like Gord and others in the building science world to help me understand the history. But I think the big question is just sort of how far back in time can you go before you run into too many legacy issues that standard solutions just isn't possible or realistic, like where's that sweet spot? And so, my hypothesis, from my consultations, but you could probably, if you look at this chart on the right, push back maybe as far as, early 80s, maybe late 70s. It seems to me as you get further back in time, you're starting to get into more time-consuming remediation work like bad wiring or asbestos. Buildings start to lack some of those basic control layers. And as I learned in my first retrofit project, the painful way, buildings just end up getting added onto and patched up beyond recognition. And you just need to peel back the layers to know what you're working with, and you're usually into a gut reno at that point.
And Tom, I will say, it's not, you're not saying, just go back to that one slide. You're not
Yeah.
saying don't do the renovation on the old house. It's just not
Oh,
going
no.
to be done at scale, right? And we see this a
Yeah.
lot. I love watching the shows where they take a century-old home and update it and modernize it. That's great, but that's the one house at a time. If you, what you're saying is, in terms of segmentation, or speed and scale, is segmenting for the purposes of speed and scale, understanding that we can get a lot more done in a 1980s house, sorry, a lot more 1980s houses done than we can 1946 houses done at speed and scale. Is that a fair characterization?
Yeah, and that's exactly it. And thank you for clarifying, Gord. Now let's talk technology. Technology is always it's an enabler of scalability. And I'm particularly, I was particularly interested in aero barrier, as we start going down this air sealing path, because it's proven to be a very effective technology in the realm of high performance and new construction. It's helping home builders consistently achieve net zero results. But it does have its challenges in the retrofit space in terms of like prep and cleanup and coordinating with neighbors. But used properly, sort of my hypothesis is that it should be able to take air sealing results to another level, just like it does in new construction. And for those you just don't know quickly, I mean it's the pictures sort of describe it's a process. You basically pressurize a house and you pump it full of air using a blower door. And then inside the place, you release an aerosolized sealant. It's non-toxic. It's tacky, and as it exits the house, it kind of gums up all the cracks and gaps, and it's really effective at sealing up a large source of air leakage in a house, which is stuff that it's just too laborious to get to. In the bottom right photo there, you can see a really good example around like a window frame, just how effective it can seal up. So that's technologically that's one of the parts that I was intrigued with at TrimTab about trying to adapt to the retrofit space. Now, the last piece on this, on thinking through speed and scale, just comes down to I say go where the demand is greatest, but I just think like where it's needed most, where energy efficiency is needed most. And my contention is that affordable housing, I think, is as good a candidate as any for energy efficiency, because it tends to be populated by tenants for whom energy costs are significant, um, either because they have high energy bills due to the poor quality housing or because their energy bills simply represent a large portion of their income. And there's been a lot of great policy work and advocacy performed by the folks at Efficiency Canada that have really brought to light the extent of it in our country. You don't want to see people getting their gas cut off and then having to heat their home with an oven, like you see here. People, I don't think it's lost on anybody that there's an affordability crisis out there, and for folks in affordable housing, energy is a significant one. So maybe just to sum up what I just shared with you on this piece about speed and scale was the core concept that we wanted to move forward with the TrimTab was to put to the test the idea of focusing on what I call post-1980s low-rise affordable housing. It's a meaningful, large scale of sort of cookie cutter housing that I think has good potential. In terms of capturing lost opportunity, interested in the idea of integrating retrofits with unit turnovers. So when tenants leave and property managers turn them over, there's an opportunity there to do retrofits. And by implication, you got to get in and out pretty fast, just because municipalities tend to mandate property managers to turn them over quick. From a technology standpoint, we want to set a hard target and say, let's not do percent better than, like you typically see in rebate programs, but let's actually set an absolute target here and see if we can achieve that. So we just picked Energy Star as a starting point to see if that's possible. And then last, and certainly not least of important, is just focusing on the things that can really improve tenant quality of life. Because I believe, if tenants, if you can really improve quality of life, I think they're going to be great caretakers for these units.
Tom, I wouldn't mind just staying on that slide just for a second. that idea of integrating retrofits you showed on a slide earlier, what roughly 500,000 houses change hands in Canada each year? Is that the stat I saw? Was it
Yeah.
535 or something? Boy, that's an interesting opportunity. And then, as you said, how much time have I got in between? In your case, because these are being funded, or at least the projects are affordable housing, they perhaps can control that a little bit and bring their tenants in. I think that's pretty fascinating. But imagine if you did this, if you had the same premise at scale with, say, traditional markets, and said to the bank, hey, could I get some bridge financing? You're going to tell us later, but just give us a hint. How much time do you need between move out and move in?
It's a
Roughly.
good question. I think realistically, you probably want to give yourself a couple weeks to a month, depending on how far you want to get. And again, that's factoring in sort of the wild card of not knowing what you might run into, even if you're attempting small scale stuff. But I think even if a month, I think is pretty good. You know what I mean? When you consider that deep energy retrofits and large scale renovations take much longer than that, Gord.
And it's an interesting premise, because then as contractors, one, you have that set group of contractors who know they have a defined piece of work, well scheduled in advance, because you know when that house is going to close. Two, now the house is empty and you don't have to worry about occupants and contents and so on. That really enables that technology, such as AeroBarrier, a technology that wouldn't be applicable if house is occupied. And then three, I really like your idea, and I want to stress to the audience this idea of a set target. Historically, it's always been do the best you can, see how well you can make, how tight you can make it. Weatherization programs in the US used to use what they called blower door directed air sealing, and they would say you have to show a 25% improvement. And it made a huge difference when somebody had an actual target. So thank you for just reiterating that. That's useful. Sorry to interrupt, but I just thought I'd wanted to stress those couple of bullets I think are really vital.
Well, I think as I'm going to get to, and I talk about funding and stuff, I mean, if you're going to be innovative, you got to be ambitious. I think, you don't, as the saying goes, you don't discover new oceans until you have the courage to lose sight of the shore. So let me talk a little bit about how we went from a concept to a project now, the story behind that. And, this is a case of, I'll admit, almost a little bit lucky, like preparation meeting opportunity, as the definition of luck goes. Um, right around the time this thinking was coming together, we started to talk to some of the local nonprofits, and we were really fortunate to find a nonprofit housing provider right in Chatham, where I'm based, that was willing to partner with TrimTab. And why were they interested in partnering? Well, as it's noted here, it's interesting. They just decided to roll out heat pumps. They hadn't even gone forward with implementation yet. They just, in their mind said, look, we want to do this. There's great rebates from Enbridge and Enercan on heat pumps, and they wanted to deal with sort of all the maintenance issues with window air conditioners, and give central air conditioning to their tenants. And so they saw the synergies of doing envelope upgrades with heat pumps and possibly an avenue to renew and deal with some of the deferred maintenance. So it just turned out timing was really good to sort of pair this up, heat pumps and air sealing. Now, we started to, how is this being paid for? I do want to acknowledge the generosity of those who sponsored the work and provided funding for it here. First and foremost, we took the idea and the partnership to the Green Municipal Fund. That's run by the folks at the Federation of Canadian Municipalities, and they provided a pilot grant because they view this as innovative work on several fronts. Now, they did have a 25% energy target, and so I'll get into that. That just sort of adds an extra element to the project. But otherwise, sort of a flexible program that gave us a chance to innovate. Second thing is we were very fortunate to get a climate change grant out of the Peter Gilligan Foundation. That's for those of you who don't know, Mr. Gilligan's the founder of Mattamy Homes, Canada's largest home builder, and they do a ton of philanthropy. And again, they too like the innovative aspect. And then lastly, acknowledgement to Enbridge Gas, and they have a great home energy proofing program that supports affordable housing through the demand side management, and they were supportive of this project and provided some customized support. Now, let's just talk about sort of the setting up the problem, though. I think those of us who are designers and engineers out there, well-defined problems go a long way. And so at TrimTab, we retain the services of building knowledge to start looking at, modeling practical upgrades to these low-rise sort of townhome units that not only hit 25% energy target, but did it subject to all the constraints you see on the slide here, right? Like working with existing plans because existing operator, housing operator decided they're going to put hybrid heating in, recognizing we got a turnover process of cars to get in and out quick, keeping capital costs as low as possible and ongoing maintenance, while serving the ultimate mission of the housing operator, which is to improve quality of life for their tenants. And it's interesting, maybe what's interesting is I'll admit decarbonization wasn't an explicit objective in this problem setting, but we fundamentally believe that when you look at sort of what we're trying to do here, there's fuel switching, there's load reduction. We figured it would just be a very good byproduct of the process. So where did it lead us? From an energy standpoint, I like to use pictures more than words here. The core of the solution involved hybrid heating on the left, so putting in an Energy Star heat pump with a backup furnace. Sealing and ventilating is the other big, focus area. And there's a lot to that I'm going to unpack in the back end of my talk here. It's more than just aero barrier. That's just one part of the process. It involves ventilating, it involves dealing with atmospheric vents and changing water heaters, but overall sort of with the goal of air tightness. And then the last piece on the right, basement insulation, because there was some half bare cold walls in these places, and the energy model showed that would be a good bang for our buck, especially if we're in there foaming headers already. Now, just quick example on the numbers. I don't want to bog you down too much in the math, but here's a representative sort of unit from the portfolio that we worked on. 1,200 square foot, 2-bedroom end unit. There's a picture of it up in the right corner of the slide. And we looked at a few of these scenarios. We modeled them in HOT 2000. That's the top part. The middle part was, collecting some additional inputs and using Volta Snap to come up with some heat gain, heat loss calculations. The bottom piece is scenario comparisons, and those scenarios are kind of what you see in the columns. First one's your base case, just heated with a furnace and gas water heater and sort of, like 1980s construction. Middle was adding a heat pump and doing air sealing. And on the right was heat pump, air sealing, and spray foaming to R12. And I think the part I'll draw your attention to at the bottom there is that, the energy reductions, are in the order of 20 to 28% there. Like, I guess you couldn't call this a deep energy retrofit, but nonetheless, you're still getting like 60 to 70% emissions reduction, and that's the clean grid advantage in Ontario, right, with the emission factors. And I think that's important to call out. And I think you got to recognize too that we're going to be adding ventilation, adding heat pumps. So I mean that offsets the energy reductions to some extent, because we're also trying to add energy services that improve quality of life in these places. Second piece I'll call out, and it's the bottom number that's circled in red, is just, if we're able to cut the air sealing in half, because I think our baseline was around 5 or 6 air changes thereabouts, get it down to 2, you're still achieving like 15% reduction in your heat loss. And that's significant, right? That's what you want, because then your heat pump can take a bigger bite out of your heating load. So that's a synergy I was speaking of earlier.
It is important, Tom, to recognize, though, you're quite right. There's folks on the call who are, say, from out in Saskatchewan or Alberta, where their grid is not in shape at the moment.
Yeah.
That you could see greenhouse gas reductions if you switch to a heat pump, because their electricity is generated with coal. That said, in years to come, as the grid cleans up, they'll still be there. So it's not an excuse not to do it. It's just a recognition that the greenhouse gas reductions might not be immediate if in a in a jurisdiction, the electricity grid isn't as clean as you might want it to be.
Yeah, and that's perfectly fair. And I sympathize with program designers like CMHC and FCM who, when they design programs at the national level, tend to ask for higher energy reductions, because that may very well be necessary to achieve those kind of greenhouse gas emissions sort of today, to your point, Gord.
And just while we're on the slide, there's a couple of pertinent questions. There's a number of questions in the Q&A, but a couple of that will be interesting. What did you say the ACH was before the retrofit? Obviously, it changes by unit, but in general, this tranche of houses that you've been working on, what would you say would be the starting range of air tightness levels?
I think we modeled it pretty sure between 5 and 6, Gord.
Fair enough.
Yeah.
You must have done a pre-test though on units. Is that kind of where you're at in most cases?
Well, we had the benefit that all these, I had the e-audit results from the heat pump rollout right before I started doing envelope upgrades. So we had a complete set of air leakage data, and then we retested before we did any air sealing efforts, which I'll show later on in results.
Oh, I see. Great. So you'll have some
Yeah.
actual, but you knowing
Yeah.
based on that, you model that 5 to 6 as being the base case based on that research.
Yeah.
That's great. And then Zoran was asking what energy reduction. He was saying in the US, the National Renewable Energy Lab defines deep energy retrofit as 50%. And you were clear to say you wouldn't necessarily qualify this as deep energy retrofit. You said the municipality was looking for a 25% reduction. As I believe. So you're not necessarily claiming deep. What I think what's intriguing here is regardless of the actual energy reduction, the greenhouse gas reduction is definitely there.
Yeah, that's right. I think, and when we talk about deep, I tend to go back to Enercan. I think Enercan makes the reference typically. I think they set the standard in their view. 50% is, I think, commonly the benchmark for
Right.
a deep. So I don't know if you call this a medium or a light. Um, but yeah, I'm not making a claim that this is a deep energy retrofit, but I think it's still interesting what else you can achieve despite only 20 to 30% reduction
Right.
in energy. Now, let's talk about the scope of the project because it's more than just the energy conservation measures. And this is important because if you've ever pulled out, I'm a renovator, so if you've ever pulled out the home builder guide on renovation, great reference by the CHBA. You know, they talk about the renovation hierarchy, and the truth of the matter is that, you know, if you go in order of priority when you're looking at a place and renovating it, it's, you know, health and safety and durability before you get to energy efficiency. Otherwise, you just won't sustain those energy efficiency benefits. So part of the project was to do upgrades that reinforced or renewed the infrastructure. So examples on the slides include putting a backwater valve in. On the left, there's Rob putting a backwater valve in. There's Riley and Connor in the center, putting a new panel and surge protection in. There's also turnover activities that need to happen with tenants coming and going. And so there's Spencer on the right, stripping down the carpet on the stairs. Now, I'm going to call out one of the challenges with the scope. So you've got, you know, infrastructure, you got retrofits, but this is the wild card, and this is actually what gets in the way of scalability, or it's a barrier to scalability, quite frankly. It's sorry, I shouldn't laugh, but when I see my carpenter Andrew there stepping on the punky floor in the bathroom, it's a perfect example of sort of not fully knowing what you're walking into when you turn over a unit. And you don't know until it's empty and everything's out of there. You know, in this case, he found deficient framing in the first floor header and had to get that fixed up. And so, you know, it's my earlier point, before you do energy efficiency retrofits, you got to get that house to sort of that baseline condition that you've assumed in the model. And that's a bit of a wild card. It depends on, this is the part you can't standardize. Now the good news though is that at least from our standpoint, you know, we show up with a multi-trade team, so it's not like you're waiting for some guy to show up. If you run into this problem, we can hit the ground running, doing repair work. But I will just be honest and acknowledge that, you know, the repair is sort of that uncertain. It's an uncertain piece when you go into this process. There could be no work, and then sometimes you run into this, and that can set you back a week. Now, I want to talk process because process is a really important part of this whole approach of speed and scale in the affordable housing space. We are integrating retrofits with turnovers. And so turnovers is the terminology used in the property management world when a tenant leaves and a new one's going to come in. Property managers, this is what they do. And so we had to, as a contractor, insert ourselves in that process between where they begin and where they finish. You know, they start by cleaning out properties and doing remediation. And that would usually mean like, that could mean like mold, bugs. Then they hand it over to trim tab. We'll do our piece. and then we flip it back to the property manager to do the finishing touches. And you know, it's this is one of the challenges at first, you know, getting into sync, two different workflows, you're trying to integrate them, and you're trying to, you know, time's your enemy, right? So you're trying to get in sync very quickly. Now, I want to talk about the air sealing process, and talk about sort of the elements of our air sealing process and what we've learned. And the first piece is about the demolition piece. You know, we're not intending to gut these places, as I've said, but you got to do enough tear down to get to the issues. You know, if you're finding a lot of air leakage in a kitchen, you might need to pull those cabinets off and take the range height out, as you can see in the left-hand photo, where you can see holes and left behind, you know, in the walls. And on the right hand side, you know, if you've got some foam board kind of, you know, and or you got to get to the headers in the basement, you know, you got to tear that stuff off to get to the root of some of your challenges. And then, so the right was quite interesting because we pulled off a bit of foam board and then we just saw the daylight pouring in at us. Pretty extreme case of air leakage, but the bigger issues wasn't just the cold air coming in. It was, you know, driving rain coming in, you know, one of the days we were working through, you know, it's ants coming in and it's just all kinds of bugs. So there's, you know, really stacked benefits when you encounter air leakage to this extent, which you do sometimes in the places where we work. Now, let's talk about atmospheric vents. This is also part of the air sealing process that has some knock-on effects on your mechanical systems. And the challenge with atmospheric or power vents is that you've got atmospheric combustion inside the building envelope, and that can present some challenges. One can be safety. You know, if you have an atmospheric vent in an airtight home, you know, you run the risk of backdrafting and the potential generation of carbon monoxide. Wasn't so much the case here because we got power vents. It just had more to do with the basic idea that, you know, it's pulling air out of the house when it runs, and so it's bringing air in. So it's more infiltration. You know, it's higher bills, it's drafts, and so part of the process was getting those vents out, getting our hot water heater out, and putting a new hot water heater in. We looked at our options, and just sort of given the realities of affordable housing and the desire for, you know, simple, cheap, affordable, and easy to maintain. We put electric resistance in, not necessarily the highest efficiency option, but we did add a little blue box on the top. You can see in the right-hand photo there, which is a scheduling controller called a Hoot Water. It's actually quite an interesting company. It's Oakville-based startup that does scheduling controls on electric resistance so that you can run these things off peak to manage costs. But that was sort of one of the corollaries of the air sealing process. Air leakage investigations. I know there's lots of energy advisors on this call that understand the importance of a good air leakage investigation. That's how you find the leaks and systematically address them. Yeah, a bit of a story here. I actually wasn't happy with the air leakage results after our second unit. We were losing all kinds of sealant in the header, a first floor header, and didn't know why. And you know, I was talking to a building science colleague, Randy, who's you know, been a good advisor to me, does really good work. You know, I was telling him this problem. He says, you know, Tom, he's like, you know, like just go get a fogging machine. Like go to the music store, get the biggest machine you can get. And you get, but remember, you gotta fog it a lot. You know, so warn the neighbors, call the fire department, and then go ahead. And so I did that, and that's what we did on the left-hand side there. And it was really quite effective at bringing to light a couple issues that we wouldn't have otherwise caught. You know, one example shown here, we saw all kinds of fog coming out the range hood exhaust. And, you know, that led us to sort of tearing apart the venting that was boxed in, and we found that the range hood was never properly connected to the ductwork. In another example, we saw an exposed floor that had no proper air barrier that was just pouring out smoke. And so that was money that paid itself back in spades because we ended up fixing those issues, and they turned out to be systematic with the houses after, right? And so that's maybe the one point I make is maybe it seems like a lot of work to go through this process, but if you're working in attractive housing, you see patterns. And so it's not like we fog tested every unit, but by fogging testing a couple early on, it gave us some really good clues into how the place was built and where some of the deficiencies were from an air leakage standpoint. Okay. this is about what you see on this photo here are 4 different trades participating in the air sealing process. You got an insulator on the left side, it's foaming the headers. You got your HVAC guy repairing or replacing a vent cap in the middle, framer doing drywall, foundation guy plugging a hole from an old vent with cement. And the details matter. That's all I would say, is that all these sort of conventional draft proofing things are still relevant. And you need the right people, with the right details. Details matter greatly when it comes to air sealing. Now, just one quick detour, and I say workflow optimization. Actually, I was going to say it's really about capacity building. With trades, it's really important, especially if you're going to undertake air tightness, a big air tightness focus, that everyone understands the goal of the project. Everyone gets that, hey, we're here to do airtight renovation work. Everyone plays a part, especially if you're putting holes in walls. And what's great about that, though, is when your trades understand that, then they start to contribute ideas on how to on good sealing details, on how to get to the root cause of some problems. And this work, and it provides a great, especially this environment working in turnovers. It's a really nice learning environment for apprentices, right? You don't have, it's just, you've got a nice, clean, open environment and time for lead hands to sort of teach apprentices about, good detailing, as you see here with this one electrician. Okay, ventilation. Any serious attempt at air sealing requires balanced mechanical ventilation. I'm sure most of us know that balanced ventilation, mechanical ventilation provides a controlled source of fresh, temperate air. It's even more effective when paired with a well-sealed home. And so we put ERVs in addition to the air sealing. And I will just say, from an installation perspective, auto balancing is huge. It really cuts down on the commissioning time to make sure that your intake and your exhaust flows are balanced. So we can get these installed and set up pretty quick. And we determine the capacity, for continuous ventilation through an ASHRAE calculation.
It's interesting that you applied that. It's always been the angst in Energuide work, when do I have to? And I'd often hear energy advisors say, well, you don't want to make your house too tight because then you'll have to put in an HRV. And there was always a calculation done on the Energuide, and Brandon, I'm sure you ran into this too. And whereas I really like your approach, we're going to put in ventilation, and therefore we can go ahead and make the house as tight as we can. That's how it's really viable. And so, Brandon, you get away from that idea of, the angst of, should I put in ventilation? Should I not? You should always put in ventilation. And Brandon, did you ever find that? Just quickly comment. I know we're running a little short of time, but quickly comment on that.
Yeah, I definitely, I'm familiar with that situation. I think when you get to some of those maybe mid to late 90s, early 2000s homes that were made more airtight, but maybe in that 2.5 range, but no balanced ventilation, then they're already getting a lot of condensation. They're like, I got to replace my windows because all the condensation, and that the windows is one part, but the ventilation is also. So it's like, you don't. There's still room there to improve it, but to apply something like an aero barrier in that situation without ventilation is probably, I wouldn't recommend it. Yeah.
Thank you. Go ahead, Tom. Sorry.
Yeah, no, and just one point on that, and this is kind of maybe more the visceral component, if there is one to HRVs and ERVs, Gord. Some of these places, they don't have good air quality. They have odor from smoke and odor, and it's like, it's amazing, between like a fresh coat of paint and running an ERV for a couple weeks, you can just smell the difference in these places once we turn them over.
Nice.
Let's talk about aero barrier. So a couple points about aero barrier. Yeah, use it to get to the small holes. It is a great tool. It's, plays a very important role in the success of our air sealing efforts. But it's not a cure-all, right? And I just want to make sure people understand that it's a tool with that has to be used the right way. Because if you don't get to your big holes before you use aero barrier, you just end up wasting a lot of sealant, and you end up annoying the neighbors and setting off their smoke alarms, and you don't want that. Um, so it's really more of a finishing touch. And in this example here, we're at the point now with our retrofits where we can prep the day before a couple units, bring the good folks over from AeroSeal Canada with one truck, and they can seal two at a time, knock a couple air changes off each unit, and clean up the same day without a lot of mess. But it does help, having to strip the places down and then bringing it in at the right time is proving to be effective.
An idea of blower door directed air sealing. If we're gonna do this at
Yeah.
scale, blower door directed, do a blower door test, find out the big leaks, do those, then bring in the technology to do it at scale. Thanks, Tom.
Yeah. One more point about aero barrier. Not only is it really effective air sealing tool, it's a good diagnostic tool if you miss any big holes. Um, because it will attempt to seal even the gaps that it can't seal. And you'll see the remnants of it after you apply the tool, the technology. Here's an example. There's Matt from AeroSeal Canada. In the midst of a seal, you can see he's got his respirator on. He's down looking at the sump pit because he realizes there's a lot of sealant going down there, and he's trying to throw some duct mask on to temporarily seal it up. But after the fact, it's like good that we know that, because then the plumber on my team he came up with a really great retrofit air sealing detail for a sump pit lid, which you see on the right, and also good for mitigating soil gas. Now let's take the last bit of time we got here and let's talk about results. I want to share some preliminary results. We're not completely through the project, but we've done 6 units. And so here's what we saw on the air sealing. Really pleased that we got to our goal. Now for 80s townhome units, they actually weren't terrible from a baseline standpoint. I consider, between 4.5 to 6. I've seen a lot worse than that. I'm sure many of you have too. But nonetheless, we got them all to 2.5 or better, which is the Energy Star. And we got 5 of them down to under 2, which is net zero for attached housing. And the one we didn't get the net zero, that was the one I mentioned earlier. It's why we did the fog test. So, going forward, we then did similar homes and got better results. So yeah, this is good, and this gives us hope that we're going to continue to get these results going forward. But these are all in the order of like 50% or better reductions in air leakage, if you just want to frame it in those terms. Maybe in the interest of time, I'll jump to here. So part of this project is doing what we call measurement and verification. That's the process of looking at validating energy savings based on actual utility data. And so, sorry, there's a lot of information here. Maybe first focus your attention on the house in the upper right there. Same example I was showing earlier, right? We retrofit the right side unit. It's got the heat pump, it's got the ERV, it's got the change in water heater, it's airtight. On the left is a baseline unit, just heated with a furnace, haven't done anything to it. And then this is just one example, we spent the winter doing weekly meter reads on gas and electricity to just see how we've influenced the actual change in energy use. And so what you now see on the slides here, or the graphs, top one is a side-by-side comparison of natural gas use. And what we show in the red box is that we've really condensed gas use in the retrofit unit to just the winter months, just for the backup furnace. And that's not being used in the summer or the shoulder seasons anymore. It's about a 60% reduction in gas use. On the bottom is the electrical usage, right? And this is where you got to, pay attention to both sides of this, right? We have doubled the electrical usage on that house between, water heater, ERV, heat pump for heating, despite lowering the heating load. Now, a kilowatt's not the same as an M cube. So, if you're to convert that all to GJs, we're still around 21% down on overall GJs, which is good. It's not way off the theory that we showed on the H2K model. But let's look at what this means in terms of GHGs and dollars. On the GHG front, just in this one example, and just over the last 6 months, we're down about 49% in emissions. Pretty good. It's actually gonna, once you factor in the whole year, it'll be higher. It'll be over 50 because you know, you're just going to be capturing now shoulder season and summertime where there won't be any gas use in the retrofit unit. So I'm pretty confident that once we get a year of data, we're going to be well over 50%. And it was a pretty cold winter too, factoring that in. But that's I think a good, you know, good directional data point early on in this process. The energy story's got a bit of a twist. Yeah, the headline says we reduced the tenants, and the tenants are paying all the bills here, by the way. We've reduced the tenants' energy costs by almost 30%, which is awesome. It's not because we've lowered the utility bills per se. If you look at just the red and the blue bar on both the baseline and retrofit unit, the total is similar. I think the retrofit's even up slightly, like at maybe $5 a month. Probably not noticeable to the tenants. But the big energy savings in this case, and this is where we had planned for the big energy savings, is in eliminating the rental water heater bill for the tenants. There is a lot of rental water heaters in this space. And don't get me wrong, I'm not opposed to financing equipment in principle. I don't think it makes sense in this situation. And it's a big benefit to the tenant because they're saving $40 a month on a power vent water heater. And so you can see they've already saved over $200 just over the last 6 months, and it'll be over $400 by the end of the year. So that's a big win for the tenant, on top of sort of gaining a better indoor environment and not really seeing their utility bills go up any perceptible amount. Okay, so on the turnover time, since you asked, Gord, this is how it's gone so far. So what we're measuring is the incremental turnover time. Property managers have their normal amount of time they have to turn over units, and we're just trying to measure how much extra time does the retrofits and repair work sort of add. And so you can see early on, and you know, it's always clunky the first few, you know, you're trying to get into a smooth workflow. And once you get a few reps under your belt, we're down from 70 days to 40 days just after 6 retrofits. And you know, we didn't really know what a good target would be at the outset because we're doing this for the first time, but we're getting to 40 comfortably, and our goal is to get it down to 30 by the time we get our next 6 retrofits done. And great feedback from tenants. Great feedback. Tenants that are moving in are all noting better air quality, love the central air conditioning, love that they have fewer bills to pay, and it's all contributing to better quality of life. Now, maybe just in closing, this is my last slide. What's next? Well, we're starting to also test this approach on stacked townhomes. We've got another project in Woodstock with another housing operator. That's the housing complex you can see in the photo on the right. And we've started to turnovers that integrate energy retrofits, sealing, ventilating, electrifying in a matter of weeks. As we go through these units, and we don't have results in that yet, but maybe that's something we can share at a future point in time. And maybe just to summarize, Gord, I think, you know, what we've shown so far, I think it's supporting evidence to this, you know, to the overall question of this webinar is air sealing and heat pumps, are they a good combination? Can they put a real dent in emissions? And I would say so far, based on what I'm seeing, I think it does. And I'll just stop there.
And stop there just for a second, and then we'll move on to other slides. But I just want to recap that. If I used, you know, my son's example, 4 months, 4 contractors, 4 different contractors, didn't and improved the quality of life significantly, saw some nice savings. But you're talking 40 days in this case to now do these units at turnover. I just think it is demonstrating. I think you're right. You've demonstrated the case for this, that in this subset, as you said, tranche of houses of specific age, and in this case, attached units, specifically units that are under distress, and we want to improve quality of life, we're showing that we can get this done. The keys being, I'll just remind folks, because some of the questions here are, Zoran's asking, does addressing air tightness make sense before building upgrades? Well, air tightness is a building upgrade, of course, and it's something that can get done at fairly low cost, as opposed to replacing all windows in the house or recladding a building. It is something that can get done as part of the turnover work. I think that's pretty powerful. And we know that air tightness is the single biggest component of the heat loss So if you're looking to put in the smallest possible heat pump or get the best possible advantage out of a small heat pump size, maybe I'll put it that way, air leakage is your best bet, right? That's where you want to head first. So it does make sense to do as part of this. What I think, not to miss out in Zoran's comment, there's really only 5 things that you can do to enclosure. You can improve the attic, you can improve the walls, you can improve the basement, you can improve the windows, and you can make it more airtight. Well, which of those can you get done upon turnover? Attics are pretty much already topped up. So in this case, Tom, you did the basements and the air leakage and the heat pump. Those were the 3 elements, just to remind. And I always say to clients, my experience has been, get at least 2 things done out of 2 out of the 5, and then that makes heat pumps more viable. So I just really appreciate, and I think you have addressed the idea of, could we do this at scale? And so you have, tell the folks what you're now working on, and as an example of how successful this has been.
Yep, no, and we're gonna, pardon me, Gord?
I was gonna say, as I understand it, you have another project on the go that you're real close to landing.
Well, yeah, you know what? Well, I will just say, like, I talked about this one. I think this is going to be, I think it'll be a good challenge if we can take this approach across portfolios. I think if you can, I think then you're going to really start to convince people that scalability is possible. It's good to show it in one portfolio. So with stacked townhomes, where there's going to be some additional challenges with air sealing because you've got more shared walls, I think it'll be another good test. And then we're already, there's another project forthcoming where we're looking at doing this to a block of homes down in Windsor. So I think property managers and housing operators are turned on to the idea, not just for the energy efficiency benefits, but just because of all the non-energy benefits that go with air sealing. And I got lots of stories on that front, maybe for a future presentation.
Yeah. Michael's asking, and I can understand why. He says, with all the variables identified as a contractor, how do you quote for these projects? How is this done? Is it a cost plus? Is it a set fee? How are you doing that?
Yeah, good question. It's brownfield work like this is managed on a cost plus. You build a budget, you build a contingency, and you manage not to, you work to not to exceed it, obviously. But you do have to be upfront with property managers, and I think they get it because a lot of them are accustomed to dealing with the wear and tear of tenant housing, and so they understand that it's hard to know exactly what you're walking into before you clean out the place and you can fully assess it.
It's been my understanding, my experience, that those property management firms, that turnover, they do in fact have a pretty standard budget, right? They'll say to the corporation, here's what we can get done for X dollars, and we'll spend that dollars, we'll do the best we can with those dollars. And I could see this being a similar model, right? That here's the fixed fee, here's how much we'll get done. We'll do whatever we can for those dollars. If we find something that's pretty disastrous, we'll let you know. But I could see it becoming a pretty standardized formula. And again, Michael, to remember, this is a specific tranche of houses. We know about these houses, right? It reminds me of, I don't think Peter is going to mind me sharing. He was saying, how are we going to get at these existing houses? He was saying, when we build new houses, we build a full street of them. Why wouldn't we go back to that same street of houses now that we know they're there, 40 years old? We know what's in every one of those houses. Could we not just march down the street? And we would know. We have all the plans. We know what the installation levels are. We even know what the duct sizing is. Why wouldn't we just go down those same streets again and work away at them? So I think there is ability here to both control time and cost and outcomes when we think about these kinds of speed and scale elements. So
Yeah, I'd like to add a point to that, Gord, because on your thought there. I mean, it does, again, this is the benefit of working in a tranche of housing. It does, your ability to predict what you're going to see does get easier after you get a few reps under your belt. So, costs do become more predictable as you get to the 5th and the 6th and the 7th unit. The energy retrofit piece in and of itself, like, hey, I'm going to put an ERV, I'm going to change the water heater, I'm going to spray foam walls. Those are predictable costs. It's the repair piece that is the uncertain, element that you're walking into. And sometimes it's nothing. Sometimes it turns out to be significant. And, with a little bit of history, you can start to predict it based on a historical average.
Right. And then some other comments, what about apartments and condos? Exactly, apartments and condos, a set tranche of buildings. So there's another segmentation. John
Yeah.
saying, why does the approach not go the next step to cold climate heat pumps with electric backup? And Tom, I think you've got an answer for that, and it's going to vary by project, but go ahead and your thoughts on that.
Yeah, I think higher performing heat pumps would have been really nice to test in this project. It's just that the truth is coming into this project, it wasn't a decision I had control over. So the clients that I worked for on that case study, had decided they want to go down the hybrid heating route. You got to remember their priority is to serve the needs of affordable housing tenants. They don't like making big changes at a time. I think hybrid was a nice, sort of no compromise solution in their view. But certainly, I think if you would have been able to have a cold climate heat pump in these units, as opposed to an Energy Star one, with or without a gas backup, I think it would be interesting to see just how much further you could take these results, and I'd be curious to see how much it would impact the cost too. But in this one example that I'm pointing out here in Woodstock, it's actually going to be a full electrify using heat pump ventilators.
And indeed, the Enbridge program that is running now in retrofit with the IESO is looking at cold climate heat pumps. How far can we go? And it really does come down to available panel. One of the factors is the available panel size, how much electric resistance going to have, in which case now I have to maybe do more to the enclosure to get the sizing down so I don't have to have as much electric backup. So there's added elements to it. That's great. Dan was asking to use a quality installation standard for air source heat pumps or for heat pump commissioning. And Tom, you will know from that, it goes back to more to that program, that pilot program that you said Enbridge ran in the London area. And the fact was that some of those heat pumps were not installed correctly. And hence the effort is to create a standard in Canada. We know there's one in the US, ACA 310. And we feel like there's going to be certainly the new program that's been announced by IESO and Enbridge has elements to it of commissioning. So a better standard of commissioning and so on. So thanks for that question. And Zoran did ask about the hybrid and air source. I think we've kind of answered that. By all means, let's go cold climate heat pump, but in the short term, let's not limit ourselves to getting what we can get done initially. John Breckmans was asking, what about air source heat pump or domestic hot water heaters? That is a topic for another session. I think that's on our slate of topics coming up, is how are we going to deal with hot water? So we'll chat about that one again. There's another comment or question about at what point or average winter temperature do we determine heat pumps not feasible due to the inefficiency? Some have experienced heat pump failing at -15. This is always the issue, right? And it's cold climate heat pump, and then in this case, having the gas backup, sort of the best of both worlds. Cold climate heat pump, do as much as you can, and if the house can't keep up, then we still have a gas backup. So I think that makes sense on that one. Dan was asking, do you find pushback on terms like Dan's from the US, like electrification and heat pump? What have you seen, Tom? Are people afraid of electric heat, or were they okay with this?
Actually, I'd say overwhelmingly the response has been like almost like a pleasant surprise. Like I feel like homeowners and housing operators, especially those with long memories, like you, Gord, that remember like off-oil programs and heat pumps icing up back in like the 70s and 80s. I don't know, but my father would tell me as a heating contractor, might go in with sort of a negative perception, and as long as you kind of teach them, they don't sit back your thermostat so much so it struggles to catch up. And it's like, gosh, you know what? It keeps the house pretty comfy. I don't hear too many complaints. It's the truth.
Yeah. So I do get it, Dan. Sometimes it's the messaging of, what words. We know that people don't understand what heat pump means. Clearly the industry's kind of screwed up. Why did we call them air conditioners? We call them heating systems. Why didn't we call them cooling systems? But no, we called them air conditioners. And now we have to superimpose this new word called heat pump. people don't understand that term. So there's a marketing guru in the US, Suzanne Shelton, Shelton. Go get her newsletter. She talks about all this all the time. You guys use the wrong words. You guys need better words. She's taken the word heat recovery ventilator and called it a whole house fresh air machine. Good for you, Suzanne. I love it. You know, we try to find these terms and then we realize homeowners don't understand them. John is asking, basically mentioning that when you do apartments and condos, the electrical capacity is a huge constraint. And we get that. He's acknowledging that if you can reduce loads, air tightness, HRVs and so on, that you can do that. I just want to acknowledge, John, you're absolutely right, that electrical load becomes an issue. Jerry was mentioning that we do need to be conscious of the rebate structures in low income houses. Is there something specific, Tom, are you familiar with for heat pumps in low income projects specifically? Is there an added dollars available?
Right now, the focus is more so through the IESO and Save on Energy for electrically heated homes with baseboards. They have an amazing offer for electrically heated homes. They're basically giving away cold climate heat pumps and low rise affordable housing. But on the gas side, the winterproofing program, and somebody can correct me if I'm wrong here, it still remains predominantly focused on the envelope on envelope improvement. That might change with a new framework, and Brandon, maybe you can speak to that. But right now, that's the winterproofing focus is on the weatherization aspect.
Yes, thank you. There was an early question. I'll bring you back in a sec, Brandon, but there was an early question and I don't know the answer to it. What is the estimated cost to get a low temp heat pump certified in Canada? It's a Chinese product used in Europe, but to get it CSA certified, anybody have an understanding of, anybody on this call, feel free to answer. What it would cost to bring in a new piece of equipment, get it CSA certified and NRCan listed as a cold climate heat pump. I just don't know the answer. My apologies. And then there was also a question about improving existing windows. By all means, do what you can. I'll say again, there's 5 things you can do to a house. Whichever one you can get done based on your budget. Let's work towards that. And just as we finish up, just a few slides, I'll have you click to the next slide, Tom, if you wouldn't mind. But Brandon, I'm just to bring you back in, obviously as Enbridge, now with Enbridge, but as a energy advisor initially, again, it's gratifying to folks like you and I to see Tom being able to do this at scale. And I would say to you, now working with HVAC contractors, are you confident that HVAC contractors are going to be ready to step up and help with these kinds of initiatives?
Yeah, I think this is kind of my first time hearing about TrimTab, but you know, I do really stand behind kind of the whole concept behind there and what he's trying to do. To be honest, I've thought about a similar business idea myself. You know, working in the industry, it's like, who does air sealing? Like, what company does air sealing? There's really, you know, and other than Aero Barrier, which isn't really the solution for a lot of homes, you know, and just to also really bring all of that under one roof and have that coordinated, because convenience is so important for people these days. You know, when it's like, oh, I got to call someone for the attic, for the heat pump, for the windows, it just becomes, you know, too big of a project um to kind of, you know, people don't want to like bite off more than they can chew, you know.
Right.
So yeah, good for Tom to do that.
Thank you. And
And
Tom, if
sorry,
I,
just to go back
sorry.
to the HVAC, what were you saying about the HVAC
Oh, I
again?
just wanted to, I just wanted to comment whether HVAC contractors are ready and ready and able to put heat pumps in at scale, I guess is my question.
Yeah, I think from my experience, the bigger companies out there, like, you know, maybe the top 20 Enercare, Reliance, the Atlas Cares, some of the bigger companies, they have more resources to kind of train and for the marketing of this kind of, you know, for heat pumps. I think for some of the smaller companies out there, maybe to do that extra, even though like just a hybrid system isn't really, it's not hard for HVAC contractors to learn that. But you know, when you get into some of the like the all electric, I think for them it seems like it's more, they're so busy And so to learn that extra bit is out of their scope. But I think as
We,
time moves on,
yep,
they're
yep, go ahead.
they're
Go
getting
ahead.
there.
Yeah, good. Tom, just if we checked off the boxes, one, I liked your premise of segment out houses, pick a tranche of houses that you know you can be successful with at speed and scale. Two, your understanding of that contractor base to bring them all together. Looking for that time when the project or the house is empty, I think is pretty critical. And then using technology where it makes sense, right? AeroBarrier, those kinds of things. Did I miss anything out of your premise that you wanted to highlight?
No, you nailed it. Those were the cornerstones. Thanks for
Thank you.
summarizing, Gord.
And our next session is April 10th, and Trevor Trainer, who we've had out on a bunch of calls this winter. This was a heavy ice damming winter. I'm always shocked when builders and homeowners forget that ice damming is going to be happening. Not every winter, but about every 5th, 6th, 7th winter. And sure enough, this winter was a tough one. We know the answers to ice damming. You're going to hear them from one of the leading folks on this, Trevor Trainer. Just really pleased to have Trevor coming in April. If we could go to the next slide just as we finish up. We would just encourage you to sign up for our Builder's Digest, in which case you get these kinds of topics. You'll get access to, if you haven't already signed up, I suppose, if you got to this session, maybe you've already signed up, but we'd love to have you on that list. And is there one final slide? And there we are. I'll say again, thanks for attending. Thanks as always, Brendan, to Enbridge for sponsoring. Tom, thanks so much for entering the contractor field and adding a whole new dimension to how we're going to do what was it, 18 million houses? Yeah, 15 million, I think is what we said. We knocked off three, if you will. But really appreciate it. And I just encourage people to stay in touch with Tom. I just think he's got a wonderful concept and lots to learn. I know he'll share results with folks. He's interested in making sure that this can get done throughout the country. So thanks again, everybody, for attending. See you on April 10th for the ice damming session. Thanks again, Tom and Brandon.
Thank you, everyone.
Thanks, Gord.